This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable, source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. At an electrical panel, a breaker number by itself does not tell the whole story. The circuit rating, the overcurrent protective device, the conductors, the load served, the directory, and the disconnecting method have to be coordinated by the electrical trade. My role as a general building supervisor is not to perform that design. My role is to recognize when the installation no longer makes sense as a coordinated system, preserve access, and get the qualified electrical contractor to resolve it before concealment, energizing, or inspection. That distinction matters because the tempting shortcut is to treat a breaker as a replaceable switch with a number on it. It is not a number I casually change to make a problem disappear. When a rating appears inconsistent, when a circuit has been modified, or when a panel schedule does not match the work, I treat that as a coordination issue. I do not guess at conductor ampacity, calculate a new breaker size, or redesign a circuit from the field. I compare the installed work with the approved information and bring the electrical contractor into the decision. The central idea I want you to remember is simple. Overcurrent protection works as part of a complete circuit, not as an isolated device. An overcurrent protective device is intended to interrupt the circuit when excessive current occurs. Circuit breakers and switches containing fuses are common examples in the equipment covered here. The protective device rating is not meaningful by itself. The panel directory tells people what the device controls. The required clearances let someone reach and operate it. The disconnecting arrangement determines whether related ungrounded conductors go off together. The termination quality determines whether the connection is tightened to the equipment manufacturer's requirement. Each part supports the others. Circuit rating awareness starts with restraint. A general building contractor needs enough knowledge to notice a conflict, but not to turn a coordination check into an electrical design exercise. If the plans identify a dedicated circuit, the panel schedule should identify that circuit clearly. If a circuit has been added or modified, the directory should be updated. If the installed breaker, the equipment information, and the approved documents appear inconsistent, I stop and coordinate a qualified review. I do not solve that conflict by choosing the next larger breaker. The source material for this lesson sets a firm teaching boundary. Reading, coordination, inspection readiness, and defect recognition belong in the general building discussion. Breaker sizing, conductor ampacity calculations, and load calculations do not. Those decisions belong with the qualified electrical trade and the applicable approved requirements. That boundary is practical, not timid. A superintendent does not need to calculate the electrical design to catch a panel schedule that says one thing while the field installation says another. I can ask whether the dedicated equipment is actually on the identified circuit. I can confirm that modifications are reflected in the directory. I can protect the panel location from other trades. I can make sure the electrical subcontractor is available to address rating questions before the inspector arrives. That is active supervision without pretending to be the designer. The phrase I use is coordinate, do not improvise. When the issue involves a circuit rating, I coordinate the responsible electrical contractor, the approved plans, the equipment information, and the authority having jurisdiction when needed. I do not improvise a technical answer from habit. A panel schedule is not decoration on the inside of a metal door. It is the operating map for the building circuits. The California Electrical Code requires every circuit and every circuit modification to be legibly identified by a clear, evident, and specific purpose. The identification has to distinguish that circuit from the others, and spare positions also have to be described with an approved degree of detail. The directory belongs on the face of the panel or inside the panel door. That location matters because the identification has to stay with the equipment. A loose sheet in a job binder may help the project team, but it does not replace the directory at the panel. Specific means specific enough to survive a change in occupants. A label such as John's bedroom depends on who lives there. A label such as Northwest bedroom describes a permanent location. The first label can become meaningless when the occupant changes. The second label continues to tell a technician, owner, or emergency responder which space the circuit serves. Vague labels create the same problem. If a building has several lighting circuits, the word lights may not distinguish one from another. If several receptacle circuits serve different areas, the word plugs may not be enough. I am not looking for a novel on every line. I am looking for concise identification that separates one circuit from the rest. I put a comparison table on screen that reduces the directory check to a few field questions. Is every circuit identified? Are modifications reflected? Does each description distinguish the circuit? Are spare positions described? Is the directory on the panel face or inside the door? Does the wording describe a permanent location or purpose rather than a temporary occupant? There is a related workplace rule for disconnecting means serving motors and appliances. The disconnect has to be legibly marked to indicate its purpose, unless its location and arrangement make the purpose evident. The practical connection is the same. During normal work, maintenance, or an emergency, a person should not have to guess what a disconnect controls. Imagine a hypothetical final walkthrough. The electrical work is complete, the panel is energized, and the directory has 3 handwritten entries that all say bedroom. Nothing in those entries distinguishes the rooms. The problem is not neatness. The problem is uncertainty. I would send that back for specific, permanent identification before calling the panel complete. The next coordination issue is space, and this is where 2 different rules are commonly blended together. Working space is the clear zone in front of the electrical equipment. Dedicated equipment space is the protected vertical zone associated with the equipment footprint. One is primarily about a person reaching and working at the panel. The other keeps foreign systems out of the panel's dedicated vertical area. For standard equipment covered by this lesson, the basic working space in front of the panel is at least 36 inches deep. The width is at least 30 inches, or the width of the equipment if the equipment is wider. The height is at least 6 feet 6 inches from the finished floor or working platform. The required depth can increase with the electrical conditions, so I treat 36 inches as the basic value covered here, not permission to ignore a larger project-specific requirement. I picture that working space as an invisible phone booth placed in front of the panel. The comparison is not perfect, but it is useful. The booth has depth, width, and height. If a ladder, drywall cart, shelving unit, tool chest, or stack of boxes occupies that booth, the required working area has been compromised. California workplace safety rules expressly prohibit using required electrical working space for storage. I put the 2 spaces side by side on screen because the distinction is easier to hold when the geometry and the field conflict are compared directly. Working space is in front of the equipment. It is measured for access and operation. Dedicated equipment space follows the equipment footprint vertically. It is checked for pipes, ducts, and other foreign systems. For indoor equipment, the dedicated space follows the width and depth of the electrical equipment and extends from the floor to 6 feet above the top of the equipment, or to the structural ceiling when that ceiling is lower. Plumbing, drain lines, steam piping, and heating or cooling ductwork do not belong in that dedicated zone. Suppose a mechanical subcontractor proposes a condensate drain directly over a panel. The pipe does not block the door, so someone looking only at front access may say the panel is clear. That misses the second rule. The front working space can be completely open while the dedicated space above the panel is still violated. The general building decision is to catch the routing conflict before the pipe is installed, not after an inspection requires an offset and tear out. The shortest memory connection is front for the person, vertical for the panel. Front means working space. Vertical means dedicated equipment space. That one distinction prevents a large share of panel clearance confusion. Breaker location has its own measurable limit. The center of the grip of the operating handle, with the handle in its highest position, must not be more than 6 feet 7 inches above the floor or working platform. The measurement is to the center of the grip, not to the top of the panel cabinet. This is where accessible and readily accessible can be confused. A breaker that can be reached only by bringing over a stepladder is not made acceptable merely because a ladder exists on the project. For the field check covered here, I remember the maximum handle height and verify it from the finished floor or working platform. The panel enclosure also has to remain free of debris and damaging residue. Paint, plaster, cleaners, abrasives, corrosive material, and construction debris do not belong inside electrical equipment. That means protection has to continue after the electrical contractor finishes. Drywall finishing, painting, and cleaning crews can create a defect in equipment that was previously acceptable. A useful supervision habit is to inspect the panel twice. I inspect when the electrical work is ready, and I inspect again after the surrounding finish trades have worked. The second look catches blocked access, overspray, plaster dust, stored material, and newly routed systems that were not present during the first inspection. A multi-wire branch circuit adds another coordination point because 2 or more ungrounded conductors share a grounded neutral conductor. The California Electrical Code requires a means to simultaneously disconnect all ungrounded conductors at the point where that branch circuit originates. That can be accomplished with an appropriate multipole breaker. It can also be accomplished with standard single-pole breakers, mechanically connected by an identified, manufacturer-approved handle tie. The visible field principle is not the price or style of the breaker. The principle is that the related ungrounded conductors disconnect together. The shared highway analogy makes this easier to remember. Imagine 2 lanes carrying traffic toward one shared exit ramp. Closing only one lane does not make the shared ramp inactive because traffic can still arrive from the other lane. The simultaneous disconnect closes the related incoming lanes together. The practical consequence is that turning off only one part of a multi-wire branch circuit can leave the shared neutral associated with an energized circuit. An open, shared neutral can also create a damaging voltage imbalance across connected loads. I do not need to teach circuit design to recognize the coordination requirement. If the branch circuit shares a neutral, the originating disconnecting means has to operate the related ungrounded conductors together. A common mistake is assuming that only a specialized common trip breaker can satisfy the rule. The source material supports another compliant method when it is properly identified, and manufacturer-approved, mechanically tied single-pole breakers. What I do not accept is independent handles that allow only one related ungrounded conductor to be disconnected while the other remains on. Terminations are another place where appearance can be misleading. A lug may look tight, but the California Electrical Code requires a calibrated torque tool for required new equipment terminations. That includes terminations such as main lugs, neutral bars, and breakers when the equipment instructions specify torque. The important general building lesson is not a particular inch-pound value. The value comes from the equipment manufacturer and the electrical contractor's approved work. The supervision question is whether the required torque was applied with the proper calibrated tool, not whether someone experienced says the connection feels tight. Both directions matter. An under-tightened termination can create poor contact and localized heating. An over-tightened termination can deform the conductor or connection. The torque requirement replaces guesswork with the equipment manufacturer's specified tension. Before inspection, I coordinate the qualified electrical subcontractor, the tool, and any required verification, rather than discovering at the inspection that the work cannot be demonstrated. Temporary power belongs on the same readiness check. On a construction site, all 120-volt alternating current, single phase, 15 ampere and 20 ampere receptacle outlets used by employees and not part of the permanent wiring require approved ground fault circuit interrupter protection. Temporary wiring is exposed to movement, weather, physical damage, and repeated use by several trades, so I do not treat a temporary receptacle as a casual extension of permanent power. I check the actual source serving the workers, not just the newest equipment on site. A clean permanent panel does not correct an unprotected temporary receptacle farther downstream. When the temporary installation has completed its purpose, It also has to be removed rather than becoming a forgotten part of the project. I put a compact inspection readiness checklist on screen at this point. The highest breaker handle is within the maximum height. The front working space is clear. The dedicated vertical space is free of foreign systems. Multi-wire branch circuit disconnects operate together. Required new terminations are torqued with a calibrated tool. Temporary receptacles have the required ground fault protection. The enclosure and directory are clean, specific, and complete. That checklist is not a substitute for the electrical contractor's technical inspection. It is a general building coordination screen. Its purpose is to catch obvious conflicts before they become failed inspections, unsafe work conditions, rework, or schedule loss. Consider one final hypothetical walkthrough. I start at the panel door. The directory is present, and each description identifies a specific permanent location or purpose. I look at the highest operating handle and confirm the center of the grip stays within the maximum height. I clear the invisible working booth in front of the equipment. Then I look vertically and make sure no plumbing or heating and cooling system crosses the dedicated equipment footprint. I ask the electrical contractor to confirm the simultaneous disconnect for any multi-wire branch circuit. I confirm that required new terminations were completed with the calibrated torque tool and the manufacturer's specified values. I check temporary employee receptacles for the ground fault protection. I look inside and around the enclosure for paint, plaster, residue, debris, and damage. If a breaker rating, conductor, equipment listing, or approved document appears inconsistent, I do not guess. I coordinate the qualified electrical contractor and the authority having jurisdiction when needed. That is the heart of this lesson. I recognize the system, protect the access, verify the identification, and escalate design questions to the people responsible for design and electrical compliance. Official preparation resources identify electrical coordination and safety as key areas within the general building scope. The useful memory connection is that a panel has to be understandable, reachable, protected, and correctly completed. Understandable means a specific directory. Reachable means proper handle height and working space. Protected means dedicated space and a clean enclosure. Correctly completed means linked disconnects where required, calibrated torque, and protected temporary power. I made an audio practice quiz specifically for this episode's material. It is audio-based, so the questions are read aloud and you answer by tapping, which is built for the way people study while driving, working, or moving through the day. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about what I covered. I read those questions and they help me understand where the explanation needs to be clearer. Subscribe so you can stay on track through every episode until you get your license. I know this process takes discipline, and I want each lesson to make the next part of that process a little more manageable.